For tonight's fun, I'll be checking the calibration on this HP5316A universal counter. And because I have a stack of them laying around, I'll be using a Trimble 4000 SSI survey grade GPS receiver to facilitate this calibration. Alright, we'll wait for that thing to pick up a fix. Here's the antenna. It's actually below ground level, but I can still get a fairly accurate fix. Still searching. Alright, so while that's searching, I'll turn this on. The oscillator oven will already have been warming up because this has standby power. So it's showing 10.000, so it's 194 kilohertz out. To do this test, what I'm using is the 1 pulse per second output on this receiver, which is enabled, positive slope, no time tag. So it'll output the time on one of the serial ports before the pulse per second pulse, so that if you need something that needs the time value. But I just care about the pulse. On the back of the receiver, I have a, this goes to the power, this goes to the GPS antenna, and this is the auxiliary connector, and it has the 1 pulse per second signal on it. This receiver is an X reference station, so it actually has an external clock input. So if I wanted to override its own internal 10 megahertz clock, I could. So that 1 pulse per second output comes out on this cable here, and I have the ground is red and the signal is blue. So up here at the counter, the GPS 1 pulse per second signal goes into the B channel. The A channel goes to the counter is connected to itself. That goes around the back to the 10 megahertz output this counter has. Onto the A channel, it's set for a positive edge trigger on A and B. And then the counter mode is set to a ratio A over B, which is the number of things that happen on A over the time of B. So this is 1 hertz. This is 10 megahertz. So basically using B to trigger the counter to count itself every second. And then we can see how many cycles the counter counts of itself in a second, if you know what I mean. And it'll show how, oh, look at that. And it just, oh. This counter was calibrated, I think, just shy of a year ago. And I don't think it's really been used that much since. And it has the internal oven-controlled oscillator, which is still warming up, which is why it's hunting right now. But the calibration is bang on, according to this GPS receiver 1 pulse per second output. Oh, and yes, I have a position fix using 6 SVs, space vehicles. Time dilution of precision is 1.9, which isn't too bad. So this receiver is running 25-year-old firmware, which explains why if I go to the date, it thinks it's 2001. The GPS time system is based off of a 10-bit GPS week number, which you'll notice this is greater than 10-bit, which is 1024. But that's because this has a correction in the firmware to add 1024 to the week number being received from the satellites. The problem with doing that is in April of 2019, the weeks rolled over again. And so this is back to thinking it's the 1999 week rollover, which is why it thinks it's 2001, even though we're, 102 weeks, so 2 years ahead. Yeah, 01, 2, yeah, that's right. So 99 plus 2 years gets us, which is 104 weeks or so. Anyway, the firmware doesn't understand that. I actually reverse engineered and patched the firmware, but this one isn't running it because this is a new one that I just got and I haven't updated it yet. None of this affects the ability for this receiver to calculate positions and produce a 1 pulse per second output, which is what's doing fine. Now here's another receiver. This one is running Nope. This one, the screen's seen better days. This was bought non-functional. This is running 732, but I don't think it's running my patched version. But this is quite a bit newer than the old version. And its 1 PPS without a fix is not really that good compared to the other one. But we'll see once it gets a fix how that changes. Alright, this one has a lat-long height fix. Let's see if I can do this without showing off my position. We can see our time dilution of precision is 4, which is crummy, but that'll come down. Does this one know what day it is better? Date. No, this isn't running. I thought this was running the patch firmware. But I wanted to show that there. So now it has a fix. We're back to bang on 10 megahertz exactly. Oh. I want to try one more to see if it's running my patched. Nope, I downgraded this one for some stupid reason. I don't know if I've turned on the pulse per section option on this. I have. Ah! No time tags. Enabled. Alright, we're pulsing. And we're 3-4 hertz below. I think that's 4 hertz, yeah. Below. And we'll watch this. Oh, what? Oh, this is running as a reference station. Ah. RTC M104. Oh, what? Off. Where? No, fixed height. Hey. Positioning mode. Of course, now it has to read. Oh, the other thing I want to check is that it's running in. Yeah, P code is enabled for L2. And we wait. And back. It's like 2 seconds later, and it picked up all the rest. A few more. But enough to get us back to exactly 10 megahertz. The catch is you need a dual input counter to pull off this maneuver. My other 2 counters up there are only single input. And they don't have... They have temperature compensated oscillators. This one has a temperature compensated oscillator. I don't think this one has anything fancy. So this, though, now that I've got this, can act as my frequency reference because I can calibrate the other meters to it. Ooh, lots of SVs. Which results in a much better TDOP. Still on 10. That 6 is the exponent. Now, what I should do, and what I did when I actually did this, not for video, is turn the gate time way up. But that means, so it takes forever. Must be a good time of night for doing GPS observations. I've never seen that plus before. Oh, this is options. This is a 24 channel receiver, which actually means 12 channel. That's 12 L1 channels, 12 L2 channels. The that's 18 channel, that's 18 channel. I think I've mixed half 24 and half 18. It just means that when it can over determine its position, but it also means that it has channels left to search for new SVs while it's using others, if you know what I mean. So if SV10 is about to drop below the horizon, this can be using one of its other channels to pick up whatever's coming up next. It's the benefit of more channels. So you can see we've got 10, 13, 15, 16, 18, 20, 23. What was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. So that's 20 channels used. So you can see there's separate L1 and L2 signals. Yeah, so the plus is one more.